So today we'll be talking about TranslateGemma. It is one of the newest models developed by Google, and it brings 55 different languages right on your laptop. So these are the contents for today. We'll first introduce the model, followed by some key attributes. Then we'll talk about the input and output specifications, followed by the training process. Also, we'll talk about the evaluation and some limitations of the model. So are you excited to bring the next gen translation tool right on your laptop? So for the introduction, what is the TranslateGemma? It is a family of open weight models which has got three variations: 4 billion, 12 billion, and 27 billion parameters variations, and it is designed for the translation task. And this release is a very major breakthrough because such tools previously used to rely on massive data centers, but it can be now run directly on your hardware. And its goal is to democratize the access for common people. So it can even translate beyond words. It can even translate directly from images. So these are some of the key attributes of the model. It can translate 55 different languages, which are both international and regional. It supports both text and image translations, and it has the foundation or architecture of the Gemma 3 family of models of Google. It has a context window of 2000 tokens, which is pretty good, and it gives the user full privacy on the data because the data never actually leaves the user's computer. So it has got a reasonable size and its performance is actually very good. So these are some of the specifications of the model. For the input, you need to provide it in a standardized format, and if you give image, then it will be normalized to 896 by 896 resolution. For the tokenization, each image will be encoded to 256 tokens each, and for the output, it will give you the translation in the language that you actually specified or mentioned. This model is built to be smart and trained to be very safe. So how was it trained? At first, it was trained using SFT or supervised fine-tuning, where it actually used 4.3 billion tokens of data. Then it was followed by reinforcement learning, which actually gave feedback to the model, and it actually used 10.2 million tokens of parameters, 10.2 million tokens of data for the optimization. And this reinforcement learning was done on a token by token level, which actually proved to be very effective for the model. So as already mentioned, it was fine-tuned from the Gemma 3 weights, and its data sources included some web documents and also some translated documents by Gemini, and also some public documents. It was trained on Google's TPU hardware, and it was also it actually used JX and ML pathways to actually generalize across multiple tasks. So it can actually translate more than just words. It can also capture the very soul or essence of the message. So these are some of the evaluations of the model. As you can see over here, that the 27 billion parameter model actually performed better than the other two because it is expected to do so. And it was measured in both metric X and Comet, which are some standardized formats for evaluating such models. This model also has some limitations. It should be used for the translation tasks, and it can have some bias because of the training data, which can contain bias, and it might be struggling with some complex data or translation tasks, or where there is some complex reasoning and open-ended tasks as well. So in a world without language barriers, what will you build next? Alright, so now let's test the model. So over here I prepared a notebook in which I used the code given in the Hugging Face page for TranslateGemma. So over here I just collected the code from here and I put it in my notebook, which I ran. So the first task I actually gave it was to translate from Czech to German for this particular sentence, which it did quite well over here, as you can see. And also I gave it a second task in which I asked it to translate from an image. I gave this image URL, and it actually translated directly from the image into text into English from Czech So over here, this is a pedestrian sign, which also includes a photo of a child. But over here, it went quite close. It guessed that it's a children's zone, and it's also operational for 0 to 24 hours over here as it is shown. So this is the result with the 4 billion parameter model. I guess with the models of higher parameters, it can do even better.